What do you think will happen when an ice cream is not refrigerated for a very long time? Will it still be an ice cream? Or will it change into a supercalifragilisticexpialidocious ice cream? Watch and learn more about matter.
No matter where you are or what you are doing, things are changing all around you. Whether they are plants growing, or woods burning, or even if you're just eating food, the materials around you are always changing in size, shape, and structure, absorbing energy or creating new substances. Now this is matter.
Hello kids, and welcome to another fun and learning episode with me, Teacher Danny. And to help us with our problem today, we invited one of the brightest students who just graduated valedictorian. And not just that, he is also a National Hall of Famer for winning 3 consecutive times in academic quest. Not just that, he also qualifies and won in collaborative desktop publishing categories and other journalism events in the National School Press Conference. That was an amazing achievement for a very young age. And he's on the line now. Hello, Kuya Paul. It was a great pleasure to be with you today.
Hello, Teacher Danny. I am very honored and I am glad to be part of your fun and learning vlog.
Thank you for accepting our invitation.
Thank you, teacher. I do hope that I would be able to express, share, and impart my knowledge to the children and students who are watching this vlog.
Now for today's video, Kuya Paul will explain all the things that are happening on materials like ice cream and other matter around us. And we will also test if he still remembers our lesson years before. Alright? So Kuya Paul, our viewers are curious to know about what will happen to an ice cream if it is not refrigerated for a very long time. Now here's what we found out. Watch this.
Just then,
Five minutes later.
A few inches later.
Fifteen minutes later. Much later.
So much later that the old narrator got tired of waiting and they had to hire a new one.
I must act. Patrick! Patrick! Patrick!
My ice cream! It's alive! Ah!
Patrick, down here!
Oh, SpongeBob, it's you!
Patrick, come down here.
The ice cream melted fast, but still it is an ice cream. And it tastes like ice cream. Now how do we call these changes again, Kuya Paul?
Yes, so physical change occurs when a substance changes in its appearance, shape, or state without changing its composition, or in other words, what it is made of. Thus, no chemical reaction is required and therefore no new material is formed.
What are reversible and irreversible changes? Melting of ice is a change
that turned ice into water. Burning of paper is a change that turned paper into ash. Folding of paper is a change that changed the shape of a paper. Growing a plant from a seed is a change that turns seed into a plant. Breaking of glass is a change that changed the form of a glass. Mixing of salt and water is a change that changed water into a mixture of salt and water. So, all these are changes. Changes can be classified into two types: reversible changes, irreversible changes. Now let's learn about them in detail. Reversible changes, or physical changes, are the changes that change the form or physical appearance of matter and do not change the amount of matter in an object. And most of the physical changes are reversible changes. Now let's see some examples of physical changes. Filling a balloon with air. Here we have a balloon. Let's fill it with air. Now its shape is changed. So, there is a change in the shape of a balloon. But this change can be reversed, as we can let the air out of the balloon, and the balloon will come back to its original shape. So, it's a reversible change or a physical change. Let's take another example of a physical or a reversible change. It is melting of ice. Here we have a cube of ice. Let it stay for some time, and it will melt. So it's changed from solid state to liquid state. But this change can be reversed. That is, you can freeze the same water and it will again turn into ice. So, melting is a physical or a reversible change. Now, let's have another example. Sharpening a pencil. If a pencil is sharpened, only its shape is changed, or physical appearance of the object is changed. Also, the amount of matter is not changed. Only some amount of matter is separated from the pencil apart. So it's a physical change, but yes, it's not a reversible change. Remember, most physical changes are reversible. Not all physical changes are reversible. Here is another example. Cutting of an apple. If an apple is cut into slices, only the shape of an apple is changed. Also, amount of matter is not changed. Only the object is divided into some parts. Also, this change is not reversible. Here is another example of a change. Making a pot out of clay. When clay is molded into a pot, shape of clay is changed. No new matter is formed, and a fresh pot can be again made into a ball of clay. So it is a physical change or a reversible change. So we learned physical changes are where shape or form of object is changed. Amount of matter is not changed, but can be divided into more parts. Or some amount of matter is separated. No new type of matter is created during this type of change. All the phase changes are physical changes, like melting, freezing, condensation, All these are physical changes. Now let's learn about chemical changes or irreversible changes. Chemical changes are those changes that change the amount of matter in an object, and some new type of matter is formed that looks entirely different from the original matter and are irreversible, that is, cannot be reversed once done. Let's see some examples. Burning a paper. If a piece of paper is burnt, it changes to ash, that is, some new type of matter is formed, that is, ash, which looks exactly different from the original matter, that is, the paper. This change cannot be reversed, that is, ash cannot be changed back into paper, so it's a chemical change or an irreversible change. Here is another example. Rusting of iron. Here we have a metal which is not rusted, and here we have a metal which is rusted. This brown rough layer you see on the metal is rust. And when a metal undergoes rusting, a new type of matter is formed, which is totally different from the original matter. And rusting cannot be reversed. So, rusting is a chemical change and also irreversible change. Here is another example. Candle. When you light a candle, the size of the candle reduces with time. So amount of matter is getting reduced. And you cannot convert back the candle to its original size. So it's a chemical change. And also an irreversible change. Here is another example. Cooking eggs. When we cook eggs, new look of eggs appears. And this change cannot be reversed. That is, you cannot convert cooked eggs back to their uncooked form. So it's a chemical change or an irreversible change. So kids, today we learned two types of changes. Physical changes and chemical changes. And we also learned that physical changes are mostly reversible, and chemical changes are irreversible.
An avocado ice cream will still be light green in color as it melts and still taste like avocado, but its physical look changes. But it is still an ice cream. So Kuya Paul, what are the other examples of physical changes?
So other examples of physical change involve quarrying or mining, dissolving salt, sugar, or any dissolvent in water, as well as slicing apart fruits and vegetables.
A physical change is something that changes the physical properties of an object or substance, like size, shape, or form. Cutting a piece of cloth is an example of a physical change. Even though the cloth changes shape and size when it is cut, it does not create a new substance. It's still cloth. Even if the pieces of cloth are sewn together and made into a shirt, only physical changes have occurred. The shirt is still made of the same substance as the original cloth, just in a new form. Another type of physical change involves changing states of matter, and water is a great example of this. Ice melts and becomes water, and water evaporates to become steam, but no matter its form, the water is still water. One way we can tell this is a physical change is that the change can be undone. Water vapor can condense back into liquid water, and liquid water can be frozen back into ice without changing to a different substance. In fact, many physical changes can be undone. For example, we know that dissolving sugar into water is a physical change, because even though the sugar and the water are mixed together, they do not combine and create a new substance. they are still just sugar and water, and they can be separated from each other. Not all mixtures are as simple to separate as sugar and water. When you mix butter, sugar, flour, and eggs, there is not a practical way to separate them again, but it is still only a physical change. The chemical change occurs when you put your mixture in the oven and add heat. Baking has many of the indications of a chemical change. The mixture in the oven absorbs heat. It also changes color and produces an odor. Gases are released, which is what helps the baked goods to rise. Finally, this change cannot be undone. You can't unbake a cake. Chemical changes occur when the particles of two or more substances are rearranged to form a new substance. For example, when you burn wood, the wood is transformed into a new substance, ash. Just like in baking, this change cannot be undone. Also like the cookies, the wood changes color, releases gases, smoke, and produces an odor. Unlike in baking, this chemical change releases heat and gives off light. Chemical changes take place all around us. Metal rusting, fireworks exploding, fruit ripening, and digesting food are all examples of chemical changes. Here are some clues to look at if you're not sure whether something is a chemical or physical change. Chemical changes always form a new substance. They may absorb or release heat. Sometimes a chemical change will cause a change in color, produce an odor, create a sound, release gases, or produce light. Chemical changes usually cannot be undone. Physical changes do not form a new substance. A physical change may change the shape or size of an object. It may change the state of a substance's matter. Many physical changes can be undone in some way. In a physical change, you end up with the same substance you started with, even if it looks different.
Hulk smash!
Yes, and teacher Danny, the original characteristics of the substance remain the same when an object undergoes physical change.
That's right, Kuya Paul. When you fold a paper, the only properties that change are the size and its shape. But still, it is paper, and no new substance is formed.
Yes, sir. Also, temperature can cause a phase change in objects. For example, when a certain substance reaches a certain temperature, causing it to either melt or freeze, these set temperatures become its freezing and melting points, thus becoming part of its physical characteristics. Thus, temperature can change the states of matter by either decreasing or increasing its temperature.
Yes, that's true, Paul. When we increase temperature of substance, the matter may evaporate or melt. Evaporation happens when matter in liquid form turns into gases, like water to water vapor, steam, and vaporizers. And melting happens when solid becomes liquid in form due to heat or increase in temperature, like melting of candle wax, ice turning into ice water, and chocolate melting. That's yummy. On the other hand, when we decrease temperature, the substance may undergo condensation and freezing. Condensation is the process of changing gas to liquid. That is why when you put some cold water in drinking glass, droplets of water are formed outside the glass. Also, when seawater are heated by the sun, water will evaporate and will form clouds. And soon, when these water droplets are formed in the cloud, they will condense and later on will be precipitates. Now, freezing happens when liquids turn into solid. Now, some liquids like oil and melted butter become hard and turn into solid when cooled. It is also possible when solid like the naphthalene balls turn into gas directly. This is also called sublimation. And so Paul, like what you are doing in the class before, can we challenge you by telling what matter happens on the following pictures? We will just give you 5 seconds per picture. So let's go!
It's quiz time!
Question number 1. Which is the process of turning liquid into vapor? Condensation, evaporation, or freezing?
Time's up!
The answer would be evaporation, sir.
Question number 2. Which is the process of turning solids like an ice into liquid? Freezing, sublimation, or melting?
Time's up!
I think, sir, that the answer is melting.
Question number 3. Which is the conversion of vapor or gas into a liquid? Condensation, freezing, or evaporation?
Time's up!
That would be condensation, sir.
Question number 4. Which process turns liquid into solid as a result of decreased temperature? Sublimation, freezing, or deposition?
Time's up!
That, sir, would be freezing because you have mentioned the decrease of temperature in the substance.
That's correct, Kuya Paul.
And question number 5. Which process directly turns a solid into a gas state? Condensation, deposition, or sublimation?
Time's up!
And that would be sublimation, sir.
Good job!
The inner machinations of my mind are an enigma.
You're a genius! Here's additional learning from Kuya Paul.
Yes, sir. Volatile substances such as alcohol, ammonia, naphthalene, or perfume evaporate quickly when they are poured on an open surface. Non-volatile substances, on the other hand, such as sugar and table salt, do not evaporate quickly.
And so, to sum up our learning, take it away, Paul.
So, yes, sir, physical change is what happens when a certain characteristic of a substance can be observed without changing, or when a change in state or phase occurs due to the addition or removal of heat. But we must remember that there is no new material formed in the process.
So that's it, everyone. Now, thank you, Kuya Paul, for giving time for our young learners today.
Yes, thank you very much, Sir Danny, for this opportunity.
You're welcome!
I hope that I was able to impart and share my knowledge to our future young curious scientists. Goodbye!
Bye!
Goodbye, friend.
Now, before we end this video, don't forget to like and subscribe this YouTube channel. And happy eating and learning! Bye-bye!